let's try another example of limits at infinity. And I'm going to modify this because I left the minus off. So let's take the limit as x tends to negative infinity of the square root of 100x squared minus 5x plus 2 all over 7 minus 2x. You'll recognize this as the function that we looked at in the previous example, but now we're looking at the limit as x tends to negative infinity. Alright, so the thing we're going to want to do is what we did last time, which is to divide the bottom by x and divide the top by x. But now we're going to need to turn this x into a square root. So because x is tending to negative infinity, the x's that we're interested in are the ones that are less than 0. So recall one of our preliminaries said that when x is less than 0, that x is equal to, well, I think it was negative x equals the square root of x squared. Or you could multiply each side of that equation by negative 1 and rewrite it as x equals negative square root of x squared. And I think that's what I'm going to do. I'm going to think of this x as negative square root of x squared. So what we do next is going to resemble quite a bit of what we did in the previous example. I'm going to combine these square roots into a single square root. So that's 100x squared minus 5x plus 2 over x squared, and I'm putting it under a single radical. Now what am I going to do with that minus? Well, it's outside the radical, so I'm going to leave it outside the radical. So it's right there. And then the bottom becomes 7 over x minus 2. Alright, now I think I'm going to move this minus outside since it's basically it's basically multiplying this by negative 1, so it's a constant. So we've got the negative limit as x tends to negative infinity, and I'm going to go ahead and do this division. That'll be 100 minus 5 over x plus 2 over x squared. And the denominator stays the same. So at this point, every term that consists of a constant over a power of x tends to 0. And so we're left with negative square root of 100 over minus 2, that's negative 10 over minus 2, which is 5. So this answer is different from the limit as x tends to positive infinity. So let's finish up by talking about horizontal asymptotes again. So here's our definition of horizontal asymptote. Let f be a function. If the limit as x tends to infinity of f of x equals L, then y equals L is a horizontal asymptote of f. Furthermore, if the limit as x tends to negative infinity of f of x equals m, then y equals pardon me, m is a horizontal asymptote of f. Now, y equals L is going to be a horizontal asymptote as we go out to the right side, go out on the right side of the graph. So as x tends to positive infinity, of course, the far right side of the positive x-axis. Whereas y equals m is going to be a left side horizontal asymptote. And so as the graph goes out to the left, the graph will start following that horizontal line. Some functions have both, some functions have one or the other, some functions have neither. Let's have a look at this example. Find the vertical and horizontal asymptotes of f of x equals 6 minus 5x divided by the quantity 7 plus 4x. Alright, so we've just talked about horizontal asymptotes. Let's do those first. To find the horizontal asymptotes, remember that what we do is we take the limit as x tends to infinity of the function. Since the numerator and denominator are both polynomials and they're of the same degree, we can use that trick with the leading coefficients to determine the limit. It would be negative 5 over 4. And if we take the limit as x tends to negative infinity, well, the same thing is going to happen. We get 5/4 in each case. So the equation of the horizontal asymptote would be y equals negative 5/4. Now the vertical asymptote we should be able to take care of quite quickly. We're looking for places where the denominator is 0 but the numerator is not. So we set the denominator equal to 0, and that gives us 4x equals negative 7, or x equals negative 7/4. And that's not going to make the numerator 0. The only thing that would make the numerator 0 would be 6/5, I think. So our vertical asymptote is x equals negative 7/4, and our vertical asymptote is negative 5/4. Let me say that again. Our vertical asymptote is negative 7/4, and our horizontal asymptote is negative 5/4.